Hi everybody, in this video on percents, we're going to focus again still on applications, but this time on interest specifically. So more to do with money, but thinking more about interest. And interest we're going to see actually affects things like your savings accounts and also loans as well. As just two main applications there of interest. So before we get started, there's a few definitions we need to go through. So first is, what is interest? So interest is money charged for using other people's money. So for instance, if you borrow money from a bank, so let's say you get a student loan to pay off your, your college education, or you take out a car loan, or a credit card or something like that, you are paying interest to that bank or that company to use their money, right? So they're basically loaning you, let's say $10,000 for your car, which you have to pay them back, but you also have to pay them a little bit extra. You're not just paying back the 10,000, you're paying back more than that. And that extra amount there is the interest. It also works the other way. So when you have a savings account and you leave your money in a bank, they pay you interest, because what the bank is doing is your money is not actually just sitting there in some vault. It's actually being used to give other people loans, to make investments, and so on. So the reason that you get paid interest into your savings accounts is because the bank is using your money for their own investments. So it works both ways. So interest is the money that we charge for using other people's money, whether it's a loan or a savings account, etc. The principal, or the principal amount, is the amount of money borrowed, loaned, or invested. So if you had a loan for $10,000 to buy a new car, the $10,000 is the principal. Or let's say you have a bank account with $500 in it, that $500 is the principal. So it's that total amount of money that you are using either because you've borrowed it for a loan, or maybe you're investing it. So you have it in a savings account, or other sort of investment, retirement account or something like that. The interest rate is the percent used in computing interest. Okay, so the interest is the actual money. So let's make a note here. Interest is money, principal is money, rate is a percent, right? So for savings accounts, at least right now, the interest rate that you're earning is typically very, very small, maybe a fraction of a percent or a very low percent, like 1%, 2%, half a percent, something like that. On a loan, rates are still pretty good right now too. So maybe your loan is for 3% or 5% or 8%. On credit cards, interest can get very, very high. You could have rates that are 20% or 30%. So your interest rate can vary depending on what kind of account it is, and even from account to account. So different credit cards have different rates, different savings institutions have different rates for their savings accounts, and so on. Unless otherwise stated, the rate is understood to be per year, or an annual rate. So if your rate on your loan, let's say, is 10%, which is high, but let's say it's 10%, you would pay 10% on that loan over the course of the year, right? So you're not paying like 10% every single day or something like that. So typically rates are given in an annual way, so at a yearly rate. All right, and then finally, when interest is computed on the original principal, it is called simple interest. And we do have a formula for it. It's I equals P times R times T, or sometimes you'll just see I equals PRT like that. Because if there's no symbol in between, it does mean multiplication. So I stands for interest. So it's your simple interest. Your P is your principal. So that loan amount or that savings amount. R stands for your rate. So it's your interest rate. And T stands for time, which is typically in terms of years. Now, you don't have to have a loan or a savings account for an entire year, for instance. I mean, usually loans are long-term, but particularly for a savings account, if you want to open one up for only half a year, you could do that. So your time could be a fraction. It could be like 1/2 to represent half of the year, and that's fine. But it's typically given in years. So this is the formula that we use. Now, we're going to do two things in this video. We're going to start with simple interest, which is, as it is named, simple. So it's like a one-time calculation that we do on the original principal. In reality, most interest that is calculated is done using what's called compound interest. And we'll talk about that later in the video. But to do compound interest, we actually need simple interest first. So let's start with some more basic examples, and then we'll get into what's called compound interest, which is actually used a little bit more or a lot more in the real world. Okay. So let's find the simple interest after 3 years on $1,200 at 4% interest. So with simple interest, it's a one-time calculation. So what you're going to assume here is that maybe you're depositing $1,200 into a savings account for 3 years and you are not touching it, right? So in reality, this doesn't usually happen. So that's why I said we're going to get to what's called compound interest a little bit later. But we need the simple formula first to get there. So with simple interest, it's a one-time calculation. So it's like pretend like that money is in the account for 3 years. It's never been touched. And at the end of the 3 years, how much interest would you have earned on that account? So I equals P times R times T. So notice here we have 3 years. So that's our time. So T equals 3. The $1,200 is your principal. And then the 4% is your rate. So 1,200 times 4% times 3 years. Now, 4% we do have to still change over. So just like in the other examples, you can't work with that percent. I am going to use decimals here because that tends to be what most people use. So it's going to be 0.04, moving it 2 spots to the left. And then I simply just have to take out my calculator and multiply this all out. And I can just multiply it in one shot here. So I'm just going to do 1,200 times 400, so 0.04 times 3, and I get 144. And remember, this is in dollars. So the interest earned is $144. So for instance, if this was your savings account, let's say, and you took that $1,200 to invest it for 3 years at 4% interest, at the end of the 3 years, you would still have your $1,200 and you'd also have an extra $144. So the interest is that extra fee that the bank, and if it's a savings account, the bank is going to give you to say, hey, thanks for letting us use your money for 3 years. Here is your money, let's say back. Let's say you want to close the account. Here's your money back. Plus here's an extra $144. So that is the interest here. So a student borrowed $5,000 for 8 months at 7% simple interest for a down payment on an apartment. Find the simple interest the student paid. Now, obviously, this is a very short-term loan, so you do want to be careful with short-term loans that you could actually pay this back. So perhaps the student maybe had just graduated and they knew they had a new job lined up so that they'd be able to pay it back pretty quickly. So they're going to take out $5,000 for 8 months at 7% simple interest so that they have a down payment for an apartment. Maybe they need first, last, and security deposit, but they didn't have it up front. So they took out a loan. We're going to find that simple interest. So we have I equals PRT. So our principal here is the amount of the loan. So that is the 5,000. The rate here is the 7%. And then just be careful, it's for 8 months. That is your time. So I'm gonna do a little bit off to the side here. So if our time is 8 months, but time has to be in terms of years, we need to know how much this is in terms of a year. So think about your fraction part over total, right? 8 months, and there's 12 months in a year. So if I simplify this by 4, this would be 2/3 of the year. So I'm going to multiply this by 2/3. Now I am going to change this over. So 7%, that 2 spots to the left there. So I have my interest is 5,000 times 0.07 times 2/3. Now I am going to use a calculator here anyway because interest is usually in terms of money, right? And then we use decimals for money. We don't usually use fractions. So if I'm using my calculator, I can do this with a fraction. I just want to be careful here. So I'm going to start by entering the 5,000, and then I'm going to multiply it by 0.07. And then what I can do if I want to do this all at once, depending on what kind of calculator you have, you may or may not be able to do this, is I'm going to put that 2/3 in parentheses. Oops, 5,000 times 0.7. I'm going to put that 2/3 in parentheses. And that way my calculator knows that that's a fraction. It's 2/3, so it should kind of stay together. And then I hit enter. So my interest is going to be about 233.33. So if I round to 2 decimal places, I get 0.33 here. Now, let's say you don't have a calculator that can do all of this at once. So what you're going to do instead is you're going to do the 5,000 times the 0.07, hit enter. And then think about your fraction here. 2 is in the numerator, 3 is in the denominator. So you're going to multiply by 2, and then you're going to divide by 3. So I'm just using order of operations here, and I'm going left to right. So 5,000 times 0.07 times the 2, divide by 3. And you can do it in your calculator that way, breaking it down. So the interest paid is $233.33. So the student will have to pay back the 5,000, of course, and then also they're going to pay back an extra $233.33 in interest to the bank here. Okay, so let's say a person invested $2,000 at a simple interest rate of 6% for 1 year. what total amount of money will they have at the end of the year? Oops, sorry guys. So here we're not looking for just a simple interest. I want the total amount this person has earned. So your total amount of money is going to be your principal plus the interest. So I do still need to find the interest first. And then I'm going to add it back to the principal. So my principal here is the 2,000. My rate is that 6%. And my time is 1 year. So it's just going to be 1. Don't forget, you do need to change that percent over. So it'll be 0.06. And then I'm going to use my calculator here. And I get exactly $120. So the interest earned on the account is $120, which means her total is going to be the original 2,000 plus 120. So she'll have, or he'll have, $2,120, or they'll have. So whoever this person is, will have $2,120 at the end of the 1 year. Okay, so we can find the interest, and we can also add it back in at the end to find the total, right? So we've kind of been talking about this already, we just haven't actually done an example with it. So this is simple interest. Now, what really happens in the real world is going to be more like compound interest. So let's talk about those definitions and see how it works. So compound interest is computed not only on principal, but also on interest already earned. So what ends up happening here is, and this is what typically happens. So let's think about your savings account. So let's say you have $500 in the savings account. Typically at the end of each month, you get a bank statement and you'll see a little bit of interest on there. So maybe at the end of the first month you earned, I'm going to keep it simple, $1 interest. Well, what the bank does is they add that $1 automatically back into your savings account. So at the end of the month, instead of having $500, you have $501. So the next month when they compute interest, they don't compute it on the 500, they compute it on the 501. So maybe the next month you earn $1.01. They're going to add this back in. So now you have $502.01. And then they'll do it again, but now on the $502.01. So compound interest means that, yes, you're still using that simple interest formula to compute interest, but you're adding that interest back into the account. So what happens is that principal is growing each month. It also works for loans as well. It's a little bit hard to understand, and we have a different formula that we can use that also computes compound interest quicker that we'll see in a little bit. But it also works that same way for loans as well, where you're paying interest each month on that loan rather than just paying it at the end of the year. So again, it's kind of brought in much more frequently rather than just waiting till the end of a year or waiting to the end of 2 years or 3 years or whatever the calculations we have been doing. So let's look at compound interest. Now, Now, interest can be compounded annually, semi-annually, monthly, quarterly, daily, or even continuously. Um, and that refers to how frequently interest is added back in. So annually refers to once a year. Semi-annually is twice a year. So this actually ends up being every 6 months. Monthly is obviously 12 times a year. So each month. Quarterly is 4 times a year, right? Because a quarter means 4. So this ends up being every 3 months. Daily, now daily is a little bit weird, so I am going to make a note here. So 365 times a year, or 360 times. So some banks still use what's called a banker's year, and instead of considering a year to be 365 days, they'll consider it to be 360 days. This is really an older idea because if you think about it, before we had calculators and computers and things like that, these calculations would have to be done by hand or using tables and things. So 365 is a really difficult number to work with if you're trying to do computations over and over again. So what they would do is they would round every month to 30 days, and they would consider it to be 30 times 12 or 360 days in a year. So some banks still use a banker's year instead, but a lot of banks now have adjusted to the 365 days because of computers. So just a little side note there. And then continuously, we're not going to worry so much about in this class. It uses a little bit more advanced algebra, but continuously would mean that the computer is continuously recomputing interest and adding it back into your account. So probably faster than this, but like think about it every second, just continuously redoing it. Now, you would think that maybe continuously is extremely high and going to make you rich. It's not. Continuously and daily computing are actually pretty close. They're continuous is still a little better, but they are very close. So continuous computing, although it is good, it's not going to get you like super rich overnight or anything like that. It doesn't work that way. So these are the how often interest gets computed. Now, interest may be getting computed daily, but you still may be only receive your bank statement once a month. So you'd have to actually check on your individual accounts to see how the interest is being computed at home. Again, normally we receive statements monthly. So we assume interest is computed monthly, and a lot of times it is. But it doesn't have to be. They could be computing interest daily, for instance, on like your savings account, but just sending you your statement once a month. So it's just something to check into. But I will say that most statements that you receive monthly, like loans and stuff, do this interest calculation once a month. So just something to keep in mind here. So let's do an example, and then you can kind of see what it means. Suppose $2,000 is invested at 7% interest compounded annually for 3 years. Find the total interest earned at the end of the 3 years. Okay. So notice that it doesn't say just interest or simple interest. It actually says interest compounded annually. So if you're compounding it annually, look up here to your notes. They're going to do this once a year. So this is a once a year calculation. And we're going to do this for 3 years altogether. So we're going to start with the end of year 1. So think about your interest formula here. So at the start of all this, we're looking at $2,000. The rate is 7%. So 7% is going to be 0.07, right? Moving that decimal over. So 0.07. And then the time here. So think about this. If it's annually, I'm going to come up here and make some notes here. Your time is going to be 1 because the calculation gets done only once a year at the end of the year, right? So our time is going to be 1 here. So if I multiply this all out, I get $140. So my new principal is going to be the original $2,000 plus the $140. So I have $2,140. But it's only been 1 year. So now I'm going to do my second year. I use the formula again. But my principal is different now. It's not 2,000, it's 2,140. My rate doesn't change though, and my time is still 1 year, because if we're computing it annually, we're doing this calculation at the end of every year. Again, I'm just going to use my calculator here and save us some time. We're going to get exactly $149.80 in interest. You're going to notice the interest is going to go up. So when you have a savings account like this, because your principal is increasing each month, your interest increases each month too. So your new principal is going to be the 2,140 plus the 149.80. So you're looking at $2,289.80. Now I'm just going to come over here just so I can stay on the same page. So now finally we're in our third year because we're doing this for 3 years. So our interest here is $2,289.80 times that 0.07 or multiplied by, excuse me, I know I always say times, which is terrible. I get $160.29. This is approximately, so I did round here to 2 decimal places. And finally, your new P, or your new principal, is $2,289.80 plus the $160.29. So at the end of the 3 years, you have $2,450.09. So again, these are approximate because you are rounding. But the bank would round 2 as well, right? To 2 decimal places. So at the end of 3 years, we started with 2,000 and we ended with $2,450.09. Now, this is the total principal, but my question asked for the total interest earned. So I just want to know the extra that I earned. So to find the interest earned, I'm going to take that 2,450.09 and subtract the original 2,000. So that's how you find your interest earned. You take the final amount minus the original. And you get $450.09 in total interest here. So this is what really happens when we have loans and we have savings accounts and investments and things like that, is that as interest gets computed, it gets added back into your account at the end of the compounding period, whatever that is, whether that is annually or semi-annually or monthly or whatever, etc. And the other thing that's kind of cool is that the more you compound, the more often, the more interest you earn. So you would rather have an account that compounds monthly than annually if it's your savings account, right? For loans, it works the opposite way. You want to save money, but for savings accounts, the more you compound, the more often, then the more interest you end up earning over time. Okay. So just some other notes here before we move on. So annually is once a year, so your time there is always going to be 1. Actually, maybe I'll write these on the left. Your time is 1. For semi-annually, think about this. You're doing it every 2 years or every 6 months. So every 2 years. You're doing it, sorry, twice a year, excuse me, or every 6 months. So your time there is going to be 1/2 because you're doing it every half a year. For monthly, your time here is going to be 1/12 because you're doing it each month. So 1 month out of 12 months a year. For quarterly, you're doing this 4 times a year. So it's going to be 1/4, every 1/4 of the year, which is every 3 months, right? 3 over 12 is 1/4. For daily, your T would be either 1 over 365 or 1 over 360. Okay, so just to note, if you see other examples that are not just annual, you can still compute it using the same formula, but your t is going to change here. So your t is, 1 or 1/2 or 1/12, 1/4, etc., depending on how complicated it's going to get. Now, you can see that this is pretty tedious, right? So I did this annually for 3 years. So that's only 3 computations, and it takes quite a while to do. So we don't really want to have to do this every single time. So we do have a shortcut formula for compound interest. Actually, and let me clarify over here too, that these t values are when using this simple interest formula, okay? Right. So our shortcut formula here is A equals the principal times 1 plus R over N to the N times T. So A here equals the total amount in the account or on the loan. P is still your principal. R is still your rate, so your interest rate. N is the number of times compounded per year. So if you look at the page before, if it's annually, it's once a year. If it's semi-annually, it's twice a year, and so on. Okay. And then T here is the number of years. And just be careful here. So don't use pounding T from last example. So when you have the shortcut formula, it's just the straight how many years. Like if you're doing it for 3 years, T is just 3. Notice it's a little t, not a capital T. So if you're doing it for 2 years, T is just 2 here. So this is like a regular T. This is not these T's over here. So these T's you only use if you're trying to do the long version of compound interest with the simple interest formula. If you're doing the short version, you don't have to do that. So your T is just a regular answer. All right, so let's do some examples. Okay, so $1,800 is invested at 2% interest compounded annually. Find the total amount after 3 years. So again, if we want to do it the long way, we could do it like the last example. Here we're also doing it annually for 3 years, so it'd be the kind of same 3-step process. But I want to use the shortcut formula. So here we're finding the total amount. So that is the A. That's what we're trying to find here. So what do we know? Well, our P here is our principal. That's the 1,800 that we're starting with. Our R is 2%, and you do have to put it in decimal form. So it's going to be 0.02 once we move 2 spots to the left. Our N here, so it says annual, so N is going to be 1. And our t here is 3 because it's for 3 years. Okay. Now, if the time was only for half a year, then you would still use a fraction 1/2. But typically when we're compound interest, it tends to be for full year or longer. But if you did have it just for half a year or something like that, that's okay. You could still use a fraction there. So I'm going to go ahead and plug everything in. So I have 1800, 1 plus, let's see here, I have 0.02 or 1. I'm just plugging in my values. I know it looks kind of tricky, but I'm just replacing my r with 0.02, my n with 1, and my t with 3. And I'm going to simplify before I do anything. So 0.02 divided by 1 is just 0.02. 1 times 3 is 3. So I'm using PEMDAS here. I'm kind of combining a couple steps in one. So I'm simplifying inside the parentheses. I'm also doing this little exponent because that's a pretty quick calculation as well. But I do need to keep going inside the parentheses here. So I'm going to go ahead and add those values, 1.02, and then I have that third power. Now, when we're working with this formula, you need to do your exponent first before you multiply, just like the order of operations says. So you're going to want to plug that into a calculator. Now, if I have a more advanced calculator like this one here, so I would just write 1.02, and then you're going to see the little up arrow here. That is your exponent. So I do up arrow 3, and then I hit enter. And I'm going to use as many decimal places as I can so I can be the most accurate I can be. Now, let's say you just have a more regular calculator. I'm going to get my other one out here. So if I go to my standard calculator on my app, it doesn't have an exponent key. I do have to turn to the side. So if you have an iPhone, for instance, I don't know about the Androids, but if you have an iPhone and you turn the calculator to the side, it actually opens up a lot more for you. And you will see exponent keys. It looks like it's right there, the X to the Y. So I have 1.02. I hit the X to the Y, I hit the 3, I hit enter, and there is my value there. So if you don't have a little up arrow on your calculator, you probably have something that looks like X to the Y or Y to the X. That's going to be your exponent key. And then I take this value and I multiply it by 1800. And I get $1,910.17. So instead of having to do those 3 calculations one at a time, I just do it all at once, which is really nice. So here's your final amount. So this answers the question here. If you want to know the total interest, you do take the A value and subtract your original principal. So if you do 1910.17 minus the 1800, you'll get what, 110.17. You can find the total interest that way. So this question asks specifically for the final amount. So at the end of the 3 years, you have $1,910.17 in your account. So you've earned $110 about in interest. All right, let's do one more example here. Okay, so $4,000 is invested, at 5.3% compounded quarterly. Find the total amount at the end of 10 years. I see that we're compounded. I'm doing it quarterly, which is 4 times a year, and then I need to do it for 10 years. I do not want to use that simple interest formula over and over again. I'm going to be here all day. It'd take me 40 times to do it, right? 4 times a year times 10 years. So I'm going to use that shortcut formula. So we're finding the total amount here. That's your question, that's your A. So my principal in this case is the original 4,000. My R is that 5.3%, but you still have to move it 2 spots to the left. So it's going to be 0.053. Now your N here is quarterly, and quarterly means 4 times a year, right? Every quarter. So there's 4 quarters in a whole. So it's gonna be 4 times a year. And then what's my last one? Oh, my T here is 10 because again, it's for 10 years. So I have 4,000 times 1 less 0.053 divided by 4. This becomes 4 times 10. We are going to use order of operations here. So inside, I am going to do that division before I add. So what I'm going to do on my calculator is I'm going to just type it in. So 0.053 divided by 4. And I'm going to use all the decimals. If you get like 10 decimal points back, use them all. So this is one of those things where these compounding formulas get rounding errors very, very easily. So if you don't use enough decimal places, enough is not even like sometimes 4 or 5. If he gives you 10, use all 10. I want to put all those values in there. Okay. Now this here is going to be my next step for exponents, but it's a simple calculation, so I can just make that 44 times 10. And then I do need to go ahead and finish adding in here. Now, remember, you do need to do your exponent first, so make sure you do that before you multiply. So I'm going to have to turn my phone to the side here. I'm going to do 1.01325. I'm going to use my exponent key, and it's going to be to the 40th power, and I get 1.69302938718015. So what I'm going to do here is I'm going to hit and actually just leave that number right in my calculator, and I'm going to hit multiply by 4,000. That's so much easier than trying to retype it again. So I get 6,772.1175. I'm going to stop there because for decimals, we're going to round to 2 decimal places. So I'm going to round here. The 7 is going to bump this one up to 2. And I get that the amount is about $6,772.12. So after 10 years, the $4,000 will become $6,772.12. Now, one other thing I want to point out with compound interest, particularly if you're talking about like savings accounts, is that we are assuming that you're not taking any money out of that 4,000, right? And you're not adding any extra to it. So in the real world, this gets a little bit more complicated because most people have to take some money out of their savings account now and then hopefully you're also adding to your savings account throughout the year, right? So our compound formula here is very good, but it does assume that over these 10 years, you haven't touched the account, which is a little bit unrealistic probably. But something like that could work really well for a retirement account, for instance. So for most of us who have retirement accounts, whether it's through your employer or elsewhere, you're putting in money each month. So that's going to change, but we typically don't take out any money until the end, or else you end up hitting a lot of penalties often. So again, you're using compound interest, but you are also adding to that account each month. So it's a great formula, but you do have to keep in mind that sometimes our accounts get a little bit trickier than just a one-time calculation. But compound interest is one of my favorite applications because we see it in any sort of investing, like a savings account or a CD, which is a certificate of deposit, for instance. You also see it in your retirement accounts. And then we also see it with loans. And most of us, have loans. You have a car loan, a student loan, you have a mortgage, you have some sort of loan at some point for most people. You have credit cards. So that interest is really coming into play. And it tends to all be compound interest, not simple interest. So this is a really important topic here.